As you can see, this is a quadratic equation in tan A, and to be able to write it as a quadratic equation, we shall have to use a Pythagorean identity to write sec squared in terms of tan squared. So what we shall do, we shall write this as 5 tan squared of A minus 5 tan A equaling to 2 into 1 plus tan squared A. So we know of a Pythagorean identity which relates sec squared and tan squared A as follows. And using this identity, you can write sec squared in terms of tan squared. So in this form, we can see that we have a quadratic equation in tan, and we just have to put it in a quadratic form. So we shall bring all terms to the left hand side, and it will become 7. You read tan squared. So if you read tan squared comes from 2 tan squared subtracted from 5 tan squared. And then minus 2 is 0. So as you can see, we now have a quadratic equation in tan, and we can use it. We can solve it using any convenient method to obtain the values of tan A. So we shall use the quadratic formula, and we shall substitute as follows. As I said, you can use any convenient method. In this case, we've used the quadratic formula because we can take advantage of using a calculator to get the roots. So we are going to get the values of A in this range for each value of tan A that we've obtained. So for 2, we are going to obtain the values of A as tan inverse of 2. And from the calculator, we shall obtain those values as, remember we need values that are in the range 0 to 360 degrees. So when you obtain tan inverse of 2 from the calculator, it is 63.43 to 2 decimal places. So we need another solution that is in the range 0 to 360 degrees. So we know from this quadrant, from the Cartesian plane, our answers are going to lie in the first and the third quadrant. So the first answer we have here is the one from the first quadrant. So we are going to obtain the second answer from the second quadrant by adding 180 degrees to this. So adding 180 degrees to this is going to give us 243.43 degrees. So these are the values of A that we can obtain for tan A equaling to 2 in the range 0 to 360 degrees. We are going to do similar business for tan A is equal to a third. And when you do that, we are going to obtain the angles corresponding to tan A is a third from a calculator. So the first answer we are getting to 2 decimal places 18.43 degrees. And once again, since our value of tan is positive, our answers are going to lie in the first and the third quadrant.
It was negative.
So, okay, what negative? Okay.
Come down, come down.
I can't go see a space or similar. I'm not go similar. So our second value of tan is negative a third. So for tan A is negative a third, we shall have A equaling to tan inverse of negative a third. So when you press tan inverse of negative a third in calculator, we are going to get negative 18.43 degrees, which is out of range. So we shall instead make use of the Cartesian plane here. We know that in such a case, our answers are going to lie in the second and the fourth quadrant. So since tan is positive in the first and the third quadrants, our answers are going to lie in the third and the fourth quadrants. So we shall have an answer here and an answer here. So the angle by which this line is inclined to the x-axis is going to be positive 18.43 degrees. So in that case, our first answer is going to be 180 degrees minus the 18.43. So when we get 180 degrees minus 18.43, we obtain from the calculator 161.57 degrees. Then our last answer will be 360 degrees minus 18.43, and we shall obtain that as 341.57. So we can now state all our answers, preferably in ascending order. We had 63.43, we have 161.57, 243.43, and lastly 341.57. So that will be our answer for this question. Thank you.